Hello, everyone. My name is Marcos Placona. I'm a developer evangelist for a company called Twilio. Just out of interest, who has never heard about Twilio before? OK, some people. Cool. So Twilio is a communications API that helps developers like yourselves adding SMS messages, voice, messaging, such as chat, and security into your applications, okay? So we have a bunch of SDKs, we have a bunch of libraries, and we make it really easy for you to add communications into your apps. But this is not why I'm here. Even though I work for Twilio, I will not be talking about Twilio right now. I'm happy to talk about Twilio later if you want to. But right now, I want to talk about something that is very dear to me. And I need to start by saying, I'm not really a hacker, okay? So all of the things I'm going to be talking about today are things that you can do yourselves. All of these things I've been showing you so far, like this intro here, are things that you can do yourselves, and you can do those yourselves to your applications or somebody else's application. My intent here today is not to turn you into a hacker. I'm sure that some of you will be way better hackers than I am, but my intent here today is to actually give you some knowledge of what kind of things people can do to your applications and what kind of things can be done to stop people from doing those things. Like I said, I deeply care about security. This is not the front of my house, by the way, but I deeply care about security, and this is why I chose to come over today and tell you a little bit about some of the things I've been playing with. But before I get started, I feel like I should get you to read these real quick, so it's not too long. The most important part here, which is what I want to make sure that you understand, is I have not really hacked your app, okay? And the reason I feel like I should say that is because when you go on stage and you talk about hacking people's applications, if I were to come here and say, hey, I hacked such and such app, companies tend to get suey when this happens, okay? This is like totally a made-up word. I made it up myself. But the idea with companies getting suey is if I come over and tell someone I hacked their app, companies might get upset with me and something may happen. So I am going to be showing you real examples here of things I've been able to do at different applications. I'm not going to tell you what the applications are. You will see some of my examples, and maybe you'll be able to imply what they are. But I'm not going to be naming names here. Like, that's not my intention right now. So let's just start from the very basic, because I feel like everyone here, or at least most people, have an idea of what an HTTP request actually is. So how an HTTP request actually works. So you have a customer, you have a client right here, then you have a server right there. Client makes a request, server returns a response. Okay, really simple. That's how HTTP works. Okay, the TLDR part of it. However, what I did in my example was I created a new actor. I created a new part to the HTTP request, which I'm representing with a parrot flag right there. And what's happening on this example I just showed you was, instead of making a request directly to the client, directly to the server, you make a request to myself. I then make that request to the server. The server returns that back to me. I return it to the client. The client has no idea what's going on. But what I'm doing now is I'm getting access to every single bit of data this client is passing or receiving. So just like that, I have access to everything, okay? So some people would say, yeah, but when you have SSL certificates, that shouldn't happen, right? We'll talk about this later, because yes, it will happen. Now, this is very important because of
be the very best.
What's right here. This is one of the biggest examples of, and the name of this hack is Man in the Middle. This is one of the biggest examples of a Man in the Middle hack, okay? Is anyone still playing Pokemon Go? Wow, no one. Well, someone there, cool. I still am as well. So I'll just very quickly tell you what the premise is in Pokemon Go. So what is Pokemon Go about? The idea with Pokemon Go is you have this application here on your phone, then you walk around and you get some Pikachus, you get some Pokemons. Okay, this is it. That's the premise of the game. There are other things you can do. You can catch some candies. You can, do other things. But the premise of it is you walk around and you catch Pikachus. Now, what happened to Pokemon Go was, as soon as it was released, some people were like, well, yeah, so I'm going to have to walk around. Usually when you walk around 2 kilometers, you get something, 5 kilometers, you get something else, 10 kilometers, you get something else. But who's got time to walk 10 kilometers? Okay? So what someone did, or what some people did, was they built this feature in Pokemon Go. And as you can guess, these are arrows that you can use to walk around. So right now, with this, you don't need to walk around yourself. What you need to do is you press the arrows, and your character will walk around for you. Okay? So this is a hack on the Pokemon Go application. Now, this is important because, again, the premise of Pokemon Go is walk around and you catch some Pikachus. And what these people wanted to do was, they didn't want to walk around. They wanted to catch the Pikachus, but they didn't want to walk around. So they got access to the API. Okay? Using the Man in the Middle hack, they got access to the API. By getting access to the API, they managed to move the character themselves, and obviously they found that they could just go and build something like this in the application. So this is just an overlay on the Pokemon Go application that lets you now walk around without having to walk around. So this is one of the stories, okay? But I have another story that is slightly more interesting. Has someone heard about Kuba Gretzky? No. Okay. I can't see way in the back, so maybe you have. So Kuba Gretzky is a Polish developer he was featured on the register. And if you can't read that from the back, it says, Polish developer hacks Android rewards app for free beer. So remember that my previous example was about Pokemon Go. Okay? So I shouldn't really call them hackers, but what the people were trying to do was they were trying to catch more Pikachus. Now, the motivation here is very different. What this developer was trying to do is he was trying to get free beers. Okay? So that's way bigger motivation than just Pikachus, at least for me. Now, the one thing I always like to point out is that this is not really Kuba Gretzky. This is the like a stock photo that was published on the register. And what it says at the very bottom is, "A strangely dressed man drinks beer." Okay? I know many Polish developers. I don't think they dress like this. But anyway, let's carry on with the story. The way Kuba Gretzky managed to hack this application was through loyalty. So how does that really work? Imagine you go to Starbucks, and every single time you go to Starbucks and you buy a coffee using the app, you get a star. Every 15 stars, you get a free coffee. In Poland, with this application, every single time you bought 5 beers, you would get 1 free beer. So really simple. Go to a bar, buy a beer, show the app. That gives you 1 beer towards your goal of 5 beers, and every 5 beers you get 1 free beer. And it just keeps on going. You can do this as many times as you want. Now, what Kuba Gretzky actually did, so he basically worked out what the process was to get 1 star on his loyalty app. So he would get 5 stars and get the free beers. Every single time Kuba Gretzky bought a beer in a Polish bar, a request would be made to an iBeacon. The iBeacon would then return that request, and the phone would then make a request to a web server. So Kuba Gretzky wasn't very interested on the beacon side of it, okay? I think if you have used the beacon before, you know they're totally insecure. Like there's next to no security on them, but he wasn't too interested on how this was going to pan out. He was interested on what happened right here when the phone actually made a request to the server. And he dug through a little bit, and he was like, okay, so what if I try and put an HTTP proxy in the middle? What if I try and see every single request the application is making to the server and see what they do? Like, what's in this? And sure enough, on his first try, he got access to this. Okay? So if you haven't seen something like this before, this is a JSON packet. It's got an HTTP request on it. Up there, you can see that it's actually making a real request, and it's making a post request to an endpoint called point. Inside that, you have an authentication token. This is plain text, okay? Like, this is not encrypted in any way. This is just plain text authentication token. What you would also get is you would also get information about the beacon. So in case Kuba Gretzky actually wanted to clone this beacon, all the information was there. Also, he got access to the product IDs. Because as it turns out, this wasn't just for beers. You could get anything else, like you could get free burgers, but he was only interested in beers, okay? So what Kuba Gretzky realized here was that every single time you made a request to this, passing this authentication token, you would get 1 extra star, or this user here, which is Kuba Gretzky's user, would get 1 extra star towards those 5 beers, okay? So every 5 requests, Kuba Gretzky would, and I'm sorry for this, go back. So every 5 requests, Kuba Gretzky will get 1 free beer. Okay, 5 requests, free beer, 5 requests, free beer. He didn't even have to go and pay for these beers right now. He would just make a request to a server and get the free beer. Now, the important thing about this is Kuba Gretzky got access to an unknown quantity of beer. No one really knows how many beers Kuba Gretzky actually got access to. He went ahead and he published this on his blog. This was back in August last year, so it's just under a year right now. And one of the interesting things about this, and going back to no one really knows how many beers Kuba Gretzky actually got access to, is if you look at this post on the bottom here, it's from the 28th of July. I went through and I looked at Kuba Gretzky's posts. He used to write blog posts every month or so. This was the last time he actually wrote a blog post. Now, could he still be drinking? I don't know. Could something have happened to him? I don't know. But this was the last time he actually wrote a blog post. And he basically detailed the whole process in this blog post. What he did, he wasn't naming names again. He wasn't talking about that specific app, but he was talking about something he did. And it's pretty clever. And basically, it all started with the motivation of trying to get free beer. He wasn't trying to do any harm to anyone other than to himself by drinking a lot of beer. But the idea here was that his motivation was beer. So remember, it started at some point with like Pokemon and Pikachus, and then it moves on to beer. And this could work for so many other things as well. Now, that's cool, but what could the developers have done to stop this? Because as you could see, it didn't really take too much for Kuba just to get access to what the HTTP request was. There was even an authentication token there, so it didn't really take too much. The first thing I usually say that they could have done is encrypt all the values. Okay? As you could see, the entire request was there. Like the whole thing was there. Nothing was encrypted, it was all plain text. So you don't really need to be a hacker, or you don't really need to know how to break an encryption key to get access to this. Now, encrypting all the values, if you are Android developers, I think this will make sense to you. But what I'm doing here is I'm just showing you how to encrypt values. So really simple. You can get, there are many libraries you can use to encrypt values. This is one. You start with a password, you start with a message, and then you encrypt your message using the password. If you want to decrypt, it's the same thing. So you've got a message down there, and you want to decrypt using your password. Okay? So at this point, people start to get a bit skeptical because they go like, okay, but you've got a password right there. That shouldn't be on your code. And yes, we're going to talk about this in a bit. But the premise of encryption is very simple. So if anyone tells you, like, oh no, encrypting is super hard, it is really not. And some encryption is better than no encryption, okay? So even if you end up with a password in your app, someone will need to decompile your app, okay? So if you have nothing, then some encryption is better than no encryption. But let's carry on. I know I just talked about passwords. I just talked about having a password inside your app. And the one reason why I say don't have a password inside your app is because ultimately it's going to end up in GitHub. So this is a story about someone else called Luke who mistakenly pushed his AWS keys into GitHub. So as it turns out, when you do that, well, first, GitHub will usually tell you that you did that and you should go and fix it, or you should go and just delete everything. If you have done that before, you will know that deleting a commit from like GitHub's history is not very simple. It's not very easy. So what happened here was Luke actually pushed his AWS key into GitHub, and what happened was in 20 minutes, so 20 minutes, his bill went up from like nothing to this. So basically what happens in GitHub is there are people just listening. GitHub has an API, so there are people listening to every single open commit on GitHub. So every single push for things like authentication token, API key, and all of the variations. So they're basically listening to this. And whenever they find something like an AWS key, for example, they start spinning up new VMs on AWS. With those new VMs, what do they use them for? To mine Bitcoins. And apparently this is like a very lucrative thing. So we are talking about a way darker hack right here, because this is actually going to cost you money. Luke was very, there's an update at the bottom of this blog post, because Luke was actually very lucky, because he managed to do that, and then when he realized, only 20 minutes after he published his key, when he realized that, he went and tried to refresh the key. So, as you know, if you used an API before, you will know that every API or every API vendor who gives you a key, they also give you the option to refresh this key. So if you make a mistake and you push it somewhere you shouldn't, you have the option to refresh. Luke went and refreshed it, and this amount here was still going up. He basically found a bug with Amazon where the keys were actually being cached. So even though you refresh that, your key was cached and it could be used. So he found the bug, he complains about it, and Amazon was like, yeah, okay, that's okay. We know you've been hacked and we're not going to charge you this. But like usually if you do that right now, you're going to have to pay for this. Even though you didn't use that, you're going to have to pay for this. Because Amazon has no way of knowing that you didn't give your key to someone, for example. And this applies to every single API. So if you have any passwords or anything inside your application, just make sure you don't push them into GitHub. But let's carry on, because we'll talk about this as well. Now, the other thing with Kuba Gretzky's example, like the free beer example, what they could have done is they could have utilized security features. Like every single device or every single thing you use, likely they'll have some sort of security feature. And obviously in this example, there were no security features being used with the iBeacons. So the iBeacons, all the information about the iBeacons was just there. He could have cloned the iBeacons. He didn't do that, but yes, sure enough, with iBeacons you can also encrypt your communication with them. So that would have been a nice thing to have, because maybe Kuba Gretzky would have stopped in there and said, oh, okay, this looks encrypted, so I'm going to move on. I'm going to do something else. Certificate pinning is the one thing that I think is very important here. And it goes back to the very beginning when I said, well, yeah, but when you're using SSL certificates, you shouldn't have a problem with that because everything is encrypted, right? So no, that's not right. Because what happens with having certificates is your application can make an HTTP request to a web server. And there's nothing really controlling that. Anyone can make an HTTP request to a web server, and there's nothing really to control that. And even if that communication is encrypted through the SSL server, it doesn't mean that I can't go and spoof that SSL server. Sorry, that SSL certificate. What happens with certificate pinning is you now get a chance to say your application and only your application can contact this web server. So in this example, we have a website here. So we have a host name, which is publicobject.com. We have the certificate right there. So again, certificate is in plain text on the code. We'll talk about this. And then you create a new certificate pinner. So now what you're doing is you're pinning your application to the server, and they can talk to each other. And that's great because no one else can do that. And obviously you can have control on your server as well to see where requests are coming from. This example here is an OKHTTP example. So if you're an Android developer, you will be familiar with OKHTTP. If not, it's a great HTTP library. There's more information at the bottom here. So there's a few links on some of my slides. Don't feel like you need to copy them now because I will be publishing the slides later. But if you want to have a look now, then there's a few links you can read more about it. Now, the other thing which I feel like was a big mistake on that example I gave is they totally trusted the device. They totally trusted that, okay, so you've got the application installed and there's really not much you can do because the application is installed and you're not going to go and decompile the application or do something like this. And, well, as it turns out, when you trust the device, too much, what can happen is people who have a rooted device, for example, they can do a lot of things to your app with a rooted device. Getting a rooted Android device is not hard. It's actually very easy. You can root a device in like 10 minutes if you want to, if you've never done that before. And I say this because what will eventually happen is if someone wants to do something to your app, the first thing they're going to do is they're going to decompile the app. And when I say decompile the app, it may sound like, wow, no, but this is really hard. Like you need to be a hacker to decompile an app. Well, this is a good example of a tool called APK tool. This is not a hacker tool. This is a tool that helps developers decompiling applications. And sometimes developers are going to want to do that because they want to see what kind of information they're exposing with their compiled applications. APK tool is it's a free tool. This is not a hacker's website or anything. This is on GitHub. It's an open source library. And if you want to run that, you can just go and install it. And what you can do with that is I have an APK right here. And with APK tool, I can just go and decompile the application. So this is what it takes. APK tool, my APK, and now I've decompiled the application. So what I'm doing right now is I'm looking for things inside this application. So I'm looking for like authentication, user, and passwords and other things. And sure enough, I actually found a place where in this application, I have that kind of information. So it didn't take me long. Like, it took me, 20 seconds to decompile an app and just find some information in there. And what was most surprising to me was I found this kind of information on a bunch of apps I downloaded from the Play Store. A bunch of them. But then, people say, like, well, yeah, like, you just showed a username and you showed the passwords, and if I'm using an API, I need to have some magic strings in my application. Like, I need to have some strings that will let me, like, communicate back with the server and everything. And this is all fine. Like, it happens. But there are ways you can go around this. So some of the ways you can go around, and I like going through them, is the first one is encrypt. Just like encrypt the hell out of it. Like, just make sure that there's nothing in your code that is actually readable. Because if you encrypt a key on one side, you can decrypt it on the other side if you're talking to your own server, for example. If you're not talking to your own server, like if you're not calling your own API, if you're calling someone else's API, what you can do is you can get your keys from a server. So instead of having those keys inside your server, make an HTTP request to your server. Be a good citizen, make an HTTP request to your server. Use certificate pinning so you have control of it. And now you can get that information from the server. And this way, what you're doing is you're making sure that now your application doesn't have anything that is insecure. It doesn't have any information that is insecure. The server has this information. And obviously, if someone was to hack into your servers, then you have bigger problems. But now you're basically moving this problem from a place where it's actually suited to deal with it. Your application is not meant to deal with it. The other example, so this is one I wrote, and this is how to store information on the NDK. So the NDK is the native developer kit. So this is where you can actually write C++ code that lives inside your application. So you can write small libraries that live inside your application, and you can store that kind of information in there. And what this does is, if you just decompile the application, you're not going to end up with something that is readable. You're going to end up with like some garbled code, which, yes, there are ways you can use a hex editor, for example, to read that, but it's way harder. Like, you're not going to end up with something that is just readable, just easy to read. If someone wants to read that, and they have the required skills, they have like, they can do some hex editing, for example, then they will find it, but it's way harder, okay? So what we're doing here is we're just adding some barriers. There's not one single thing right here that I'm going to tell you today that I'll say it's the silver bullet. Like with security, there are no silver bullets. There are ways you can protect yourself. There are ways you can make sure that you're protecting by adding, that you're protecting yourself by adding layers. But there's not one single thing that will protect you. A combination of those things will make you way more protected. Okay? So again, there's a link at the bottom here. So NZK storage, if you want to have a read about this, then this is a good place to start. And there's a sample application as well. I'm showing you how to compile and how to do it. And it's super simple as well. But then we talked about things that developers could have done to stop this. And usually when you're trying to stop something, it's because you are already pretty screwed. Because like you're trying to stop it. Like there's a problem, there's a breach. So what are the things you can do to mitigate those attacks? What are the things you can do to proactively stop those attacks? One of them, which is one I really like, is adding tampering detection. A lot of people don't know about this, but as it turns out, there's ways for you to know when someone does something to your APK, when someone decompiles your application, or when someone opens your application and tries to republish it. One example of it is if you wanted to do things like, I want to check that my application didn't have its name changed, for example. So say someone was able to download your APK, they decompile it, and when they decompile it, they just go and rename it. And this happens a lot. And the reason this happens is if you're making any money out of your application from ads, for example, what some people do is they publish it in alternative markets, for example, but they obviously use their own ads key. So they didn't have to build an application. They just went and changed yours, and now they can make money on alternative markets. So what I'm doing here is I'm checking for 2 different markets. So I'm checking for the Android vending, so this is the Play Store, and I'm also checking for the Amazon store. So those are the most common markets. But there are loads of markets out there. There are loads of alternative markets out there. So you could check for other things as well if you have it in different stores. I usually have my apps in 2 of these stores. The other thing I'm checking as well is I'm checking that the application has been relocated. So I checked for the name first. Has it been renamed? Or has the application been relocated? If my application is not being installed from Google or being installed from the Amazon store, chances are someone relocated my application. And when someone does that, now I have the option. Now I can do something about it because I can say, okay, so the installer didn't come from any of my known installers. What can I do right now? I can tell the user that they shouldn't be using this application because it's not safe to do so anymore. Like as the developer of this application, I don't endorse it anymore unless it's on one of those 2 markets right there. And I can do the same with the name. Like if it's been renamed, it's no longer my application, okay? So it's something to be used with care, but I think it's one way. It's not like an amazingly effective way of doing this, but it's one way you can protect yourself. If someone is on this business of just like relocating applications for their own gains, then this is one way you can stop that. Check the application signature. This one is also really good because every single time you publish an application, so every single time you change your application to release so it's ready to go, a signature is actually generated. So you can get that signature, and now you can check whether the application that is running has the same signature as you expect. If it doesn't, same thing. Just tell someone like, hey, this is no longer my application. Like, I didn't sign this thing. Someone decompiled and recompiled my application. I should be able to stop that. Check for rooted device. This is a really funny one because as soon as a device is rooted, as soon as someone roots a device, most of the things I'm telling you kind of go out the window, okay? I've seen developers doing things like not letting anyone with a rooted device use their applications. So I used to bank with Barclays, and I think Barclays did that for a while. And I was pretty upset because even though my phone was rooted, like I rooted because I'm a developer, there's loads of things I can see when I'm rooted. It was pretty upsetting because I now just couldn't use Barclays' application anymore. There are a bunch of people doing that. One of the ways you can check for rooted device is you can try and execute a command on that device. So in this case, if you try and execute a SU, for example, which gives you super user on that device, if you can execute it, it means that device is rooted. Hackers are always kind of trying to go around that, so that there are applications like hide my root or something that actually try and hide the fact that you have a rooted device. So hackers are always trying to, run around this, but this is one effective way you can check for root, okay? There are different ways you can do that as well. The one thing I like to say is, unless your application is not meant to run on a rooted device, I wouldn't use this setting, okay? This is like if you work for a bank, for example, then yes, you shouldn't run on a rooted device. If you don't, if you have a game, maybe running on a rooted device is actually okay, because there's a lot of people out there with rooted devices. Some devices actually come out of the store rooted already. So it's just something to look for. But yeah, this is a good way of checking for rooted devices. Check for emulator. This one is really interesting because, like, from all of the hacks I've seen out there, something like 90% of every single hack happens in an emulator. And the reason it happens in an emulator is you have way more access to see things like logs and everything if the app is running on an emulator than if it's running on your phone. So a lot of hackers actually download APKs and they put them in emulators because now they can do different things. They can change things like the network. They have like more control over the emulator than sometimes they have over a phone. So checking for emulator. And checking for it is super simple. You just check if you're checking for the Android emulator, like the native emulator, you're looking for generic. There are different emulators out there, so you've seen Genymotion, for example. You will need to check for each one of those, okay? But this gives you one way to say, hey, if you're trying to run my app on an emulator, there's absolutely no reason for you to do that. I can't think of a reason why any of the apps I built should run on an emulator. Like any of the apps I actually publish to the market, that they should run on an emulator. So this is a really good one. Like you stop people from the root, like don't run that on an emulator. Checking if the app is debuggable. So at this point, checking if the app is debuggable. Obviously, if you publish your app, if you publish your APK, it is not debuggable because you've published your APK, so now it's in release mode, okay? Some of the applications, when they are in debug mode, you can see things like the logs and everything. So developers will usually show logs when the application is in debug and not show logs when application is on release mode. However, so theoretically, there shouldn't be any applications out there on the market that are actually debuggable, right? Because they're all released to the market. Changing that is really simple, though. So I'm just showing you what to check for. So you check for flag debuggable. But changing that is really simple. And this is basically how you do it. So I've got my app here. I'm opening the Android manifest on the app I decompiled, and I'm changing Android debuggable to true. Now this application is debuggable. So it's not very hard. So checking if the application is debuggable is a pretty effective way of knowing whether someone is doing something to your app. And again, if they are, you just give a big message, or you just say like, no, don't continue. Now, this is the point where people say, well, I'm confused. Like, there's a bunch of things you talked about. There's a bunch of things I could have done, a bunch of things I can do. Like, what do I do now? Like, there's so much. What do I do? So a few things to look at. And I think there's a talk about this or like around these lines tomorrow on security. One of the things you can look at is ProGuard and DexGuard. I know some of you will know about these two tools. So ProGuard is really cool. It comes installed with the Android Studio. So if you are using Android Studio and you're working on a fairly new-ish project, then chances are you are using ProGuard unless you went and you disabled it. So what ProGuard does is it's installed by default. So if you're using Android Studio, then you probably have ProGuard installed in your project. It does stuff like name obfuscation. It does code optimization. It removes some of the redundant code. So if you have code that is not being used, that code will get removed. Therefore, you have fewer methods in your application. Your APK is also smaller, so it's pretty cool. DexGuard does all those things, plus it does class encryption, call hiding, and string encryption. It does a bunch of things, and the way it does it is very clever because, like, reading when you try and decompile an application that's been DexGuarded, it's like it looks like nothing. Like it looks like nothing. There's like Chinese characters in the middle. It's really hard to read. Okay. There's a big difference between the two of them because I think by now you can probably guess, if you've never heard about these two applications, you can probably guess that, you know, this one is installed by default, this one isn't, and the difference is this one is free and this one costs money. ProGuard, as far as I know, so the last time I checked, DexGuard's license kind of varies from anything between 4,000 euros or, 4,000 euros to like 18,000 euros. And it goes according to the number of users you have in your app and everything. So it's got a different licensing model. and the prices will increase as the number of users actually increase. But it's a fantastic tool, so it's something to look at. If you're looking for like quick gains inside your application, it's totally something to look at. And if you're not using ProGuard, I totally recommend just going and using ProGuard, because it will give you at least some of the basic protection in your app. Other things to look at, SafetyNet API is a really good one, I think. The SafetyNet API is an API by Google, and it does a few things for you. So it checks, for example, if the device is compatible with your application. So is that device actually a Play Store compatible device? If not, then you can make a decision at this point, okay? If it's not compatible, if it's like connected to a different market or something, you can make a decision at this point. But at least you know. It checks for other things as well. It checks if the device is rooted, and it will tell you like, well, that device is rooted. And the reason I like using that instead of using something like having a check for root on my code is, like I said, developers just keep on changing the way a rooted device actually displays, the kind of information it actually displays. So just checking for a rooted device on your code might not be effective every single time, because they just keep on changing and they just keep on trying to hide that. And I feel like the SafetyNet API, they keep up with those changes quite often. So all of the information you get from the SafetyNet API is usually very good. And it's usually very reliable. If they tell you a device is rooted, then you can make a decision. And I'm not saying, I don't know, close the application or give a message to the user saying they can't use your application because the device is rooted, but at least it gives you an option. Depending on the kind of market you are, depending on the kind of apps you're building, then at least now you have an option. Another thing you can look at is implement the network security configuration. This is, again, another tool by Google, and it gives you a few things out of the box. So when you start using network security configuration, you get things like certificate pinning, for example. You get debug overrides, so if someone tries to change your application into debug mode, you get overrides for that, so it won't become a debug. The downside of it is it only works on Android N, so it's only like on very recent versions of Android. There is a port that takes you back to Android 4.2, which is actually pretty good, but that's not a port that is actually official, so it's not it might not get every single update this library gets. So if you're only targeting anything from Android N and above, great thing to use. If you're not, maybe. Like, you could look at the port that takes you to 4.2, but that's an option for you, so that's something you can look at. Now, I just kind of want to close this by saying all these things I'm talking about, like I said, they are measures you can take, they are things you can put together and create barriers, create layers that can protect you. But the thing is, ultimately, the internet or mobile or anything is not a safe place. Like, don't trust everything you see just because, well, I think you know what I mean. With that, I want to say that when it comes to like safety, you need to make sure you protect yourself, because ultimately you're the developer of this application, and if something was to go wrong, it will fall down on you. With that, I've been Marcus Placona. This is my Twitter, email, GitHub. I also run a website called androidsecurity.info, which has a lot of the information I just showed you. And with that, thank you very much.